Well, we need to take this ellipse and put it in standard form. Well, to do that, we need to complete the square with the x's and complete the square with the y's. So we need to get our x's here grouped together, and then we need to get our y's grouped together. Now, we have this 43. It doesn't have a variable, so you want to take it to the other side, and so that's what we have here. Well, remember, in completing the square, you need to have a 1 in front of your variables. Well, we do have a 1 in front of our x squared, but we don't in front of our y's, so you got to take a 2 out of your y's. So you factor a 2 out of your y's, we would have this. We then want to go ahead and complete the square by figuring out what we have to add. Well, remember, you got to take your half of your 2 and square it, and so we'll put that here. And so then we'll also have it over here. Now, in completing the square, unlike with the parabolas, we're adding the same thing to each side rather than keeping it all on one side. So now we're going to take half of our 10 and square it. But keep in mind, our 5 squared is also multiplied by our 2. So that's why we've got to add a 2 times our 5 squared to the right side. Now your x's will factor into an x plus 1 all squared. Then you'll have a 2. Then you'll factor your y's, and it factors into a y minus 5 all squared. On the right side, you get 8. Now, to be in the standard form, you need to go ahead and divide both sides by 8 because you need to get in 1 over here. And the only way to get a 1 and get it in the proper form is to go ahead and divide by this number. So we'll divide both sides by 8. So we'll get this here. Then we'll get a 4 there because you have a 2 on top divided by your 8 reduces down to 1 over a 4. So the center is the opposite of your 1, opposite of your negative 5. Remember, what's underneath in front here tells you how far to go left and right from the center. And so your a squared is your 8. You take your square root, you get plus or minus root 2. So you go 2 root 2 units to the right and to the left. This right here is your b squared. Tells you how far to go up and down from your center. So you're going to go 2 units up and down from your center. Then to be able to find your focus, you want to use this. Remember, you always want to take the bigger minus the smaller, so you're going to take the 8 minus your 4. And then you get c to be plus or minus 2. And that's on your major axes. Now, since you are going farther left and right than you are up and down, you know your major axis is horizontal. Because remember, A always tells you how far to go left and right, B is up and down, and your A is bigger than your B. So your vertices would be 2 root 2 to the right and 2 root 2 to the left of your center. And so then we would get, remember when you're going left and right, it affects your x, and so we get a negative 1 plus or minus your 2 root 2, still going to be at the same height. Well, your foci, once again, is on your major axes. So that's the horizontal. So now you're going to want to go the 2 units left and right. 2 units to the right and left of your center. And just a second here. You go 2 units to the right of your center, which is at negative 1. 2 units to the right is a 1, 5. 2 units to the left would be a negative 3, 5. Now we need to find the equation of your ellipse. You know your foci. Plus 3 up 0, negative 3 up 0, and you know the length of your minor axes. Well, we know that halfway in between your foci is your center, so we know we're centered at the origin. Your minor axis is 2, and by the way, your foci are always on your major, so your minor has to go up and down. The length of it's 2 units, so you go 1 up and you go 1 down. So you know your A has to be somewhere out here and somewhere out here for your vertices. So you know your A is going to be bigger. Well, since we know that we are centered at the origin, that helps us out. So our center is 0, 0. Your B is how far you go up and down. Well, we're going up and down 1. Your C is how far you go to get to your foci, which you know is 3. So then we can use this formula here to be able to find A. So we plug in our 3, we plug in our 1, we solve it, and we get A to be root 10. So when we plug stuff into our formula here, we know our h and our k is our center, which is 0, 0, so that's why we just have an x squared and a y squared, over your root 10 squared and over your b squared equals your 1 is the standard form. Well, simplifies a little bit to be an x squared over 10 and a y squared over 1. You don't really have to have it over the 1 if you don't want, equals your 1. We're now going to go ahead and talk about hyperbolas. We had said before that the ellipse was where the sum of the two distances from your foci added up to be the same thing. Well, with a hyperbola, it's the difference. So when you take the big length here minus your small length, it's going to be a constant. Or we can continue to look at another one here. So suppose we went to this one here minus this distance here. Or if we would take this distance here minus that distance there. The big blue minus the small blue, or the big red minus the small red, or the big black dotted minus the small black dotted, all subtract to be the exact same thing. Here's the standard form of an ellipse. Once again, h and k is your center. A, B, and C. A, once again, more or less tells you how far to go left and right from your center to draw your box. B tells you how far to go up and down from your center to draw your box. You draw your box to be able to help you draw your hyperbola. C, once again, is how far you are from your center on your major axes to get to your foci. Now, in the drawing that we have up here, your C would be on your major axes. Notice for a hyperbola, your C is larger than your A, or if it was going the other way, it would be larger than your B. If your X's are first, it opens sideways in the X direction. Down here at the bottom, where your Y's are first, it opens up in the Y direction or down in the negative Y direction. So we could go ahead and play with this, and we could see what happens as we change different things here. So if we make our B bigger, you can see how it changes your shape. Or if we make our B smaller, and by the way, I just added my asymptotes in here. And we can also change our A. And you can change both of these. And you can just see how it makes your graph change. Well, we need to go ahead and find our vertex, focus, and equation of our asymptotes. But I think we'll do that on the next video.